Hello, everyone, and welcome back to Tutor You. I am Paul. Today, we're going to be talking about equations, your introduction to exponents, squaring, cubing, and finding the roots of numbers. So, let's get started with the class today. All right. So today, let me get this off of here. Oh, and there we go. So I have the topics up in the top right. I'll leave them up there for a little bit, but let's get going. First off, with the definition of equation, which it's going to be a review from the class last night, but I still want to get that up there just in case if you missed it. So let's go ahead and get this over there. All right. Oh, that's small. Let's make this a little bit bigger. So the definition of an equation, that is a mathematical statement that shows algebraic expression on each side of an equal sign. An equation may or may not contain variables. Very mathy type of statement. Basically, look for a variable or a letter and your equal sign. And for the most part, you're going to be okay with identifying an equation. Variable and an equal sign. Now let's talk about solving an equation. I'll give you some time to write this down if you're taking notes. If not, just take a screenshot for notes later. So to solve an equation, what we must do is we must isolate the variable. So isolate the variable. To solve an equation, find the value of the variable that makes the statement true. Isolate the variable on one side of the equation. Okay? So that is the key to finding the solution. When I ask you to solve an equation, what I'm asking you to do is to keep the variable on one side and put a number on the other side. Okay? All right, so let's just first take a general look at what a very simple one-step equation might look like. And that would be something like 3x equals 12. The way that you isolate the variable, the way that you get the variable by itself, is by doing the inverse operation. Okay, so the backwards, think of it like backwards day, right? So the inverse operation. So what is occurring, what is happening between the 3 and the x here? Well, that is multiplication. So multiplication is happening between the 3 and the x. Now, what is the inverse of multiplication? What is the opposite of multiplication? Well, that is division. So you do the opposite day. So 3 is what we're multiplying, so we have to divide by 3. And over here, whatever you do to one side of the equal sign, you must do to the other. That is something that maintains its truth all the way through. You're always going to maintain equality across your equal sign. That's why it has the name. So, what is 3 divided by 3? Very easy question, I hope. Well, it cancels out into a 1. We don't need to write that again now. What is 12 divided by 3? Yep, that is 4. So, on the left side now, to rewrite this, on the left side we have x equals 4. So that's a single step equation that we solved for. Notice that the x is isolated, it is by itself, and over on the other side we have a number. So we're making a very clear statement that x equals 4. All right? Not too bad. Okay. Now, I want to get into a little bit more of complex questions that you might face on the GED. Or they sound more complex. They're not actually that much more complex. So let's go ahead and get rid of all of this. And I'm going to put up there a problem, an example problem. Go ahead, you can take a screenshot or pause and write it down. Okay. Copy. Okay. So, our first example problem for solving equations is a lovely word problem. Everybody's favorite topic in math is word problems, right? The cost of an adult ticket to the ballet is $4 less than 2 times the cost of a child's ticket. If an adult ticket is $20, how much is a child's ticket? Now, like any word problem, what I want you to do is just stop and take a moment, and we're going to break this up into smaller pieces of what is being said. So the cost of an adult ticket, so we'll use the letter A for an adult, or we'll just say AT is an adult ticket. Okay. Is $4 less than 2, so is your equal sign. So AT is $4 less than 2 times the cost of a child's ticket. So let's go with CT is child's ticket. Okay? And it's 2 times the cost of a child's ticket. So we'll put the 2 there, and it's $4 less than that. So, the cost of an adult ticket to the ballet is $4 less than 2 times the cost. Oh, do you know what? I've made a huge mistake, actually, and I'm really happy I'm able to show you this, because even I can make mistakes when it comes to math. So, it is, we need to back this all the way up. Now, what is 2 times? It's 2 times the cost of a child's ticket. The adult ticket is 2 times the cost. So it's 2 times this, 2 times the adult ticket. If an adult ticket is $20, how much is a child's ticket? So an adult ticket to the ballet is $4 less than 2 times the cost of a child's ticket. Okay. So let's go ahead. I'm going to move this over. And we're going to write in there the minus $4. Okay. If an adult ticket is $20, oh my goodness. I've made grave errors, guys. It's just one of those mornings. I was right the first time. Now I'm just confusing everybody. Okay. So, we're going to erase everything, completely forget about everything that I just went over. We're going to restart the problem. Okay. We're still going to use the same variables. And that is adult ticket and children's ticket. Okay. The adult ticket to the ballet is $4 less than 2 times the cost of a child's ticket. Okay. 2 times the cost of a child's ticket. It is 2 CT minus 4 equals the adult ticket. And let me make that T a little bit smaller. And then what we are told is the adult ticket is equal to $20. Okay. Now, all we have to do is plug in the $20. So we have 2 times the child's ticket. Let me make that T smaller. Minus 4 equals $20. Now we can go ahead and we start to do our inverse operations. I always like to think of inverse operations as the reverse of PEMDAS, right? You all remember your PEMDAS. So what is the inverse? What is the opposite of -4? It is +4. Okay, so we must do a +4 to both sides because we want to maintain our equal sign. Whatever happens to one side of the equal sign must happen to the other. So not 2, +4. And we can rewrite this equation now as 2 times the cost of a child's ticket equaling $24. Okay. Now it's 2 times the child's ticket. What's the inverse of 2 times? What's the opposite of 2 times? It is divide by 2 times. So we're going to go ahead and we're going to divide both sides by 2. The 2 gets canceled out over here. It changes into a 1. It doesn't totally go away. There is that imaginary 1 there. And then what is $24 divided by 2? That is 12. And we get our answer that the cost of a child's ticket equals $12. Never forget your unit, which in this case it is the dollar sign. Very, very important to always remember what units you are working in. Okay. All right. So give yourself a second to process all of that information. And we're going to go ahead and erase all of it. It is out there. It is in the ether. It is on YouTube. So you can rewind, you can pause, you can utilize this video to whatever potential you would like. Let's move on to another problem. All right. And like I've said, and like I have in the description, these problems are very similar to what you'll find on the GED. Very useful if you are planning on taking the GED test anytime soon. The other thing that this is useful for is if you're just studying your algebra, intro to algebra types of classes, whether it's college, high school. This is all just general algebra. All right. Another fun word problem for us to do. Stephanie's age is 3 years greater than half of her sister's current age. If her sister is 24 years old, what is Stephanie's age? Okay. So I think what I'll do is I'll use for our variables, we'll use Stephanie and sisters. So we'll do S1 and S2. And S1 equals Stephanie. Okay, so Stephanie is S1. S2 equals the sister. Okay, and now we're going to go back through and reread the problem. Stephanie's age is 3 years greater than half of her sister's age. Okay, so Stephanie is 3 years greater than half of her sister's age. So her sister is older. Does that make sense? Let it sink in a little bit. Yeah, Stephanie's age is 3 years greater than half of her sister's age. So it's 1/2 of her sister's age. So I'm kind of reading it backwards. That's what I'm doing. That's how I'm figuring this out, is to read it backwards. So 1/2 of her sister's age. So 1/2 S2 plus 3 years equals S1. Okay? If her sister is 24 years old, what is Stephanie's age? So let's go ahead and figure this out. So the sister is 24, and that is S2. So I'm going to go ahead and I'll add in here. This is 24. And now we can go ahead and solve this equation. Okay? So we'll just replace the S2 because remember, variables are placeholders. So let's go ahead and 1/2 24 plus 3 years equals S1. So what is 1/2 of 24? What is 1/2 times 24? Think of it like division. In a way, it basically is. And I'll let you in on a secret. Technically, division doesn't really exist. So we have 12, that is 1/2 of 24, plus 3 equals S1. And now the answer is very clear. It is 15 equals S1. And for our final answer, we'll just say that Stephanie is 15 years old. Oops. And when you reread this statement, when you reread it, Stephanie's age is 3 years greater than half of her sister's current age. Kind of starts to become a little bit more clear. If her sister is 24, half of that age is 12, plus 3 years is 15. That is Stephanie. Stephanie is 15 years old. The reason why these word problems can be complex is that you have to think of things kind of backwards at times, where you have to break them down into pieces and then think of them backwards, right? When you're taking the GED test, it can be overwhelming to do that when you're being timed, right? So that's why it's really good to practice this stuff. And that's why I'm doing these videos, is so you can practice them with me. And you can get yourself a little bit more calmed down. You understand how you should approach these problems. Write down the variables first, and then start breaking the equation down piece by piece and thinking of it kind of backwards when you're talking about word problems for solving equations. But don't worry, don't you worry. We have more examples coming. All right. We'll delete all of this. And mind you, we're still on equations. We haven't even gotten to exponents yet. Okay. So word problem number 3. And let's get this up on there. Okay. So, yet again, another word problem. I want you guys to become numb to word problems, or they're so nice, they're so common that you don't have any hesitation approaching a word problem. The way to approach it is to just clear your mind. Don't even think about, oh, word problems suck. Because I know a lot of people think word problems suck, but they only suck if you try to approach them as the whole. If you approach them piece by piece, you're going to be just fine. So, let's go ahead and start to break this one down. The number of cellos in an orchestra is equal to 2 more than 1/3 of the number of violins. If there are 24 violins in the orchestra, how many cellos are there? Whew, a lot of stuff. So, oh, my nose, I might sneeze. Whew, sorry about that. So the number of cellos in the orchestra is equal to 2 more than 1/3 of the number of violins. So that's not... Oh, uh-oh. Sneezing attack on my stream. So let's write down our variables. So we have cellos will represent with the C. So cellos, C is cellos. Oh, that's what, third time? Third time is the charm. So cellos is the variable C, and violins we will have as V. Don't think about the question, just keep your mind clear and don't worry about it. Okay. So this is what I am reading right now. I will underline it. So 1/3 of the number of violins. 1/3 the number of violins. So let's go ahead and write down 1/3 V. At 1/3 the number of violins. And then the number of cellos in the orchestra is equal to 2 more than that. 2 more than that. So here I will underline 2 more than the 1/3 of the number of violins. Plus 2. And that equals the number of cellos. Okay, so I've successfully read the problem backwards. I have set up my equation, and now we can go ahead and plug in our variable, which we will mark as blue. So there are 24 violins. So let's go ahead and write this all out. So 1/3, and then we are going to put in our 24, because that is the number of violins, right? The V. And we're going to add 2 to that. And that will equal our C. So, what is 1/3 of 24? Another way of thinking of it, I'll put that off to the side. So, 1/3 times 24. Well, in a way, 24 has an imaginary 1 underneath it. We can multiply this. The way that looks is you just multiply straight across on your fractions, right? So it's 24/3. And what is 24 divided by 3? That is 8. So we have 8 plus 2 equals the number of cellos in the orchestra. And so that would be 10. We have 10 cellos. So there are 10 cellos in the orchestra. Go ahead, put a box. Cellos is our unit, right? For instruments. Let's think about this a little bit. So, technically, if this is true, right? If this is true, we can go ahead, if all of our math is right, so double checking your answers, we can go ahead and we can plug this back in to the original equation. This is called a check step. Very important to do a check step. So we're going to go ahead and we're going to plug this back into the equation and just double check that we have everything correct. So let's go ahead and do that right now. We have our 1/3 V plus 2. And now, instead of the 24 violins, we're going to put our 10 cellos in. Now, what is the inverse? So when we're solving, it's always finding the inverse operations. We are going to do the inverse of adding 2. So what's the opposite of adding 2? Subtracting 2. And you do that from both sides. So plus 2 minus 2, this drops away to 0. 10 minus 2, that equals 8. And we can rewrite the problem. So 1/3 V equals 8. Okay, so now you have 1/3 V. How do you do the opposite of 1/3 V? It sounds confusing, but just remember this whole idea right here, right? What is the opposite of dividing by 3, right? Because that's what's happening. When you're multiplying by 1/3, you're actually just dividing by 3. So The opposite of dividing by 3 is multiplying by 3. So let's multiply both sides by 3. And 3 times 1/3, the 1/3 cancels out. 8 times 3, that equals 24. And what we are left with is v equals 24. So we've completed our check step. We have gotten the 24 violins again. We are good. We have successfully completed the problem. We shouldn't be wrong. We should be good to go. Not too bad. So these are 2-step equations. You can have 1-step equations. For the most part, like if you need any extra help, make sure you let me know, or you can comment, whatever. But equations aren't too bad when you're just getting into them, right? As time goes on, we'll get more and more advanced with this class, and I hope you all kind of come along for those. We're not done yet, though. All we have completed for the day is the equations. Equations are done. Now, let's move on to what are exponents. I want to introduce you to the idea of exponents. Okay, so I am going to write up on here again, so you can go ahead and you can take either a screenshot or try to write this down. Kind of the idea, or my ideas, of an exponent. And let me copy this. So an exponent, not in red, we don't want to type it out in red. Exponent. It is a way of writing numbers. There is a power and a base. Or there are powers and bases, but it's just a way of writing a number. Let's take a look at an example, and all I'm going to do is I'm going to write the exponent as letters. So a to the b power. Okay? So a is the base. The base. And what is the base? Well, the base is the number you are going to multiply by itself. The number you're going to use, to put it as simple as possible. The number you will use. Okay. And b, well, I suppose you're going to use both numbers, but b is the power. Think of the power as how many times. So how many times you will do it. You will do the operation. You will multiply. Oops. Will multiply. Okay. There we go. So A is the base, B is the power. Let's just take a quick little look at what this looks like when numbers are used. So let's just say A is 2. So our base is 2 and our power is 4. What does this really look like? So right here is our key. This is what we're going to be doing. We're going to be multiplying 2. And then how many times are we going to multiply 2? We're going to multiply 2 4 times. So what 2 to the 4th power actually is, or what it's representing, is 2, this expression. It is 2 times 2 times 2 times 2. That is what the exponent is being the placeholder for. And of course, we can just solve this. So what is 2 times 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our answer of 2 to the 4th power is 16. Not too bad. The reason why I'll stick to 2s, or I might go to a 3, is because exponents, they're typically used to write very large numbers. Let's just take, for instance, if you have a calculator handy, even on your phone, if you write inside of your calculator, if you take 100 to the 100th power, there should be a little x with a little y up above it, and that's how you write in your exponents into your calculator. If you type this into your calculator, it's going to break it. Not break it, but it is not going to allow you to, it's not going to give you an answer. If you've ever heard of Google, which you have, this is the mathematical word. This is the term Google. It's a Google of numbers. It's huge. It's so big that the processor in your phone fails to deal with it, and it just gives you an error in response. So a massive exponent, takes way too long to write this number out. Now let's get into some example problems let's just talk about squaring. You've heard the term square before, like square footage, square miles, square kilometers. So what does that mean? So let's take a look, because this is actually kind of important when you're talking about exponents. So you might see the symbol, something like this, of meters squared or feet squared, kilometers squared, right? So this is an exponent. This is an actual exponent, and 2 is the power. So what that means is that it's m times m, and so on. So it's feet times feet. When you buy carpet for your house, when you buy a house, they might tell you the square footage of it. Feet times feet. Kilometers, same thing. Kilometer times kilometer. Square kilometers, how big a city is, how big your house is, how much carpet you might need. It's very usable. Like for those people that say like math, when am I going to use it? Well, you use it all of the time. You just don't think too hard on it. But it is very, very useful. So let's take a look of the square of the number 5. When I ask you to square the number 5, that would be like this. It'd be 5 squared. And what I'm asking you is, I want you to take the product of 5 times 5. And that equals 25. So all of this, 5 squared into 5 times 5 into 25, it is all the same thing. It all means the number 25. It's just different ways of writing it. Okay? So the square of a number. Now, if that's the square of a number, what would you assume is the cube of a number? So we've already moved past the introduction to exponents. We've moved past equations. So now we are on cubing. So what do you think a cube is? Well, now we're talking. So this is area, meters squared, that's area. So what would you suppose meters cubed is? Well, that is volume. We're talking about a volume. Oops, there we go. That's a space. It's a 3-dimensional space that we're taking up with volume. And everything that you can put into squares, as far as footage, kilometers, all of that, you can also bring it into 3 dimensions. You can say volume with it. So let's take a look at what, and mind you, keep in mind how big these spaces can get. Let's go ahead and take a look at, let's take a look at 5 cubed now, okay? So what is 5 cubed? Well, I'm asking you to take the product of 5 times 5 times 5. And what is 5 times 5? Well, we have our answer right here. So it is 25. What is 25 times 5? Well, that is 125. So I want you to just take a look at how big this number got by adding that 1 to the power. So from going from 5 squared to 5 cubed, we went from 25 up to 125. If we went up to 5 to the 4th, you have to multiply this number by 5 again. Right? So that would be what? That would be 525. Yeah, huge. Big, starting to get big very fast. The next one I could do in my head, but it wouldn't be too much fun. But squaring and cubing, it is another way of writing. It's very specific exponents. And on your calculator, you'll find a specific button for squaring a number. It'll just be a little X. Usually it's on the left-hand side of your calculator in the very left column, about 3/4 of the way down. You'll see an X squared. So it will look like this, the button on your calculator, and that is the square button. Square button. Okay. Not too bad. So squaring and cubing, it's not too crazy. Now let's talk about roots. So I'm not crossing off cubing or squares yet, because roots are connected to all of this. Do you remember what, let's pull this example back up. Do you remember what is the A in this? It's the base. Where is the base? Right? Like, and I'm speaking generally. Where is the base of any object? It's at the bottom, right? Where do you typically find roots? That's black on black. Oh. Where do you typically find the roots of things? Well, the root is typically underneath. It's at the very base of a tree or a plant. It's at the bottom. Roots. The base and the root are very much so related. Okay? So the symbol, let's just talk about roots. The symbol for taking the square root, let's just talk about square roots. So now we've connected that word square and then root. So square roots. Square roots. Okay. What does this look like? Well, it looks like this. And I'm not even going to use a variable on this one. Let's just take a look at 4. What I'm asking you is, what is the base of the number 4 in terms of squaring? Okay? Let's think of our powers again. So we'll think of it still in this sense, but A to the B equals 4. Okay? And then what we are told is that B equals 2. This equals 2. So A squared equals 4. So what is A? So A times A equals 4. So what does A equal? It has to be the same number that goes into both spots. So A times A that is, what could it be? It's only one number that it could, well, technically it's two numbers, but I'll tell you. Okay, so it's 2 times 2. So a is equal to 2. So the square root of 4 is 2. So it's the base. This is the base. What they're asking you when you do the square root of something, it is 2 square root 4 equals a of the idea of a squared equals 4. So kind of like it goes back and forth. It goes back and forth between these two. So the square root of 4 equals a squared equals 4. They are just like how subtraction is the opposite of addition. That is also true for the squaring a number and the square root of the number. They are opposites of each other. Same thing with cube roots. So let's look at some example problems of something that you might find on the GED. Let me delete all of my stuff. And I will finally delete the definition of an exponent. So our first example problem is over here. And so this is something that you might find on the GED. Oops, there it is. And it's way too small for you guys to see. So let's just bump this up to, let's go to 36. Okay. Now, like I said, this is a question. You'll find something similar to this on the GED, and I want to help you guys get this so it's easy when you come into it, when you run into these types of problems. The length of a square can be determined by finding the square root of its area. If a square has an area of 84 square meters, what is the length of a square? A lot of square words in this. A lot of square. Hey, there's a good math joke. We have too many square words going on. The length of a square can be determined by finding the square root of its area. So we want to do the square root of something. What do we want to do the square root of? We want to do the square root. We're only given one number. Don't make it more confusing. Don't get lost in the words. 84 square meters. So we want to find the square root of this 80, or not 84, 81. Oof. 81. So what is the square root? And I'm going to write it out. And you don't always have to put the 2 here. It's just kind of nice. You know its square root at that time. So what is the square root of 81? What am I asking you? Think back on that exponent example a little bit. I'm asking you, there is a number times a number, and that equals 81. There's only one number. Well, okay, I keep saying that, and I will go back on it later on. But what is a positive number where you multiply it by itself and it equals 81? Something times something equals 81. Well, it is 9. X equals 9. 9 times 9 equals 81. The square root of 81, that is 9. It's the base, remember? So the exponent, the opposite of this, the other way of writing this right here, I have a great way to show you this. So what happens if we take the square root of 9 squared? What does this equal? So this is 9 squared, right? Up here, 9 squared. It's just like when you do the inverse operation. So the square root is the inverse of the exponent that is squared. Ugh. It's navigating a fine path of words, right? But the main thing that you should remember is, in this situation, the square root and the power get canceled out, and we are left with 9. The same thing is true. Let's just say it's the cube root of 9 cubed, right? That is the same thing. So inverse operations, that's what I want you to remember. That is the same thing as just writing 9 again. They cancel each other out when they're equal. They have to be the same. If we wrote, something like, let's just think of some other different examples here. We don't even need numbers. We can do this same thing without numbers. So, x squared equals x. They cancel out. Okay. Before I move on to the next example, there is one specific thing that I want you to remember. You will be asked this question on the GED, or you'll find something very, very similar to it, even in your college algebra classes. If and when you decide to move on to college, you will find this is the easiest question, and nobody should ever get it wrong. It is, what is the something to the power of 0? Okay, so let's just go with x to the power of 0. And I just need to tell you it is 1. So this is something I want you to remember. If you only take one note down, take this note down, because it's the easiest answer. Anything to the power of 0, except for 0, there's some debate, but anything to the power of 0 is 1. If you have 1,000 to the power of 0, that's 1. If you have 57 to the power of 0, that's also 1. If you have 42, the answer to the universe, that is also 1. Anything except for 0 to the power of 1, or to the power of 0, is 1. Plain and simple. Just remember that, and you're going to be okay. That's at least one question you'll get right on whatever test or GED exam that you take. Okay? Very, very nice and easy. Let's do another example problem dealing with squares, cubes, and roots. Okay. Oh, I haven't. There. Now we can move on. And our next one. Another way of writing it. It's good to get exposed to these things. It's good to see what you're going to be up against whenever you take a math test, right? So let's bump this size up. Carlos completed x cubed squats as part of his football workout. If x equals 5, how many squats did he complete? They're writing out this fancy word problem, but it's just very straightforward. I'll show you, I'm sure some of you have already just solved this. It's something you can do in your head, but let's break it down. Let's really look at what's happening. So it is x cubed, and then they are wanting to know what it is when x equals 5. That is our statement. That's our question. So we'll rewrite the problem as 5 cubed. And what does that equal? Well, that is 5 times 5 times 5. What is 5 times 5 times 5? Yep, 125. 125. And that is our answer. So this guy, Carlos, is a beast. He has completed 125 squats for his football workout. It's a pretty good workout, if you ask me. Not too hard of a problem. I want you guys to study these things because nobody should be getting them wrong. You just went through this with me. It is very, very nice. The big thing to remember is to keep yourself calm when you're reading word problems, because some people, their anxiety just spikes when they're reading the word problem, and it's very hard for them to focus on what is actually happening, what they are really asking you. We'll move on to another example. Okay. Copy. Bump the size up. There we go. So, the length of a side of a cube can be determined by finding the cube root of its volume. If a cube has a volume of 64 square meters, oh, you know what? This should not be square. Hang on. What did I just say though? Cube volume, not square. Cubed meters. Cubed meters. Okay? Cubed centimeters. What is the length of the side? Okay? So the length of a side of a cube can be determined by finding the cube root of its volume. If a cube has a volume of 64 square meters, centimeters, what is the length of a side? So cube root of the volume equals the length of a side. Okay. So, what is our volume? We are given the volume of 64 cubed centimeters. Okay? So, rewriting this, the cube root of 64 centimeters cubed. So what times what times what is 64? That's what I'm asking you. So x times x times x equals 64. So what is our x? What is x being the placeholder for? Can you get it? Okay. So it is 4. X equals 4. Let's just work it out. Double check my own math. So 4 times 4 times 4. What is 4 times 4? It is 16 times 4. 16 times 4. That is 64. Whoop. There we go. Bingo. Bingo, bango, bongo. We have our answer. So our base, this is not our answer, but our base is 4. Our answer is 4. So the length of the side of the cube is 4. The way to kind of visualize that, let's see if I can draw this. Here, I'll use some nice little squares. We can go like this. Give ourselves a little bit more room. And boom, there we go. We have a cube. Kind of neat. It's like a magic trick. We can even color it. But I promise, this will help some of you. We want to visualize this a little bit better. And there we go. There. Okay. We have our cube. 3 dimensions. Volume is always 3 dimensions. It said that the volume of this cube is 64 centimeters. And that means that the length here is 4 centimeters. So this is 4 centimeters. Volume on the inside, the space is taking up, is 64 centimeters cubed. centimeters cubed. That unit is what you write as cubed. Okay. All right. Let's see. Do I have another example? Yes, I do. We are going to do one more example, and let's route it back. Let's start off. Let's finish up this class with what we've started with, and that is going back to equations. So we've completed our cubing review and our roots review. And if you have any more questions, don't be afraid to comment. If you need any extra help, if you need real hands-on help, I do have my tutoring service. The website is www.tutoru.net/mind, and you can get yourself some hands-on assistance with all of this. But let's just go ahead, and our problem here, this is going to be a challenging one. It is something like this. We have a triangle. Okay? A crazy big triangle. Oops. This is going to be an equations problem. Okay? And the side over here is going to equal 2a minus 1. The side over here will equal a. And the side down here will equal 2a. If I asked you to find the equation that represents the perimeter, can you do it? Let me help you out. Okay? So it's working with equations. I'm not asking you to solve the equation, but I am asking you to write it out. So the equation for the perimeter. What is the perimeter of something? If you've watched any of my prior videos, you should be okay with that, but we're going to be adding all of the sides up. Okay? It's as if you are walking around the outside of this triangle and you're measuring the distance. So this plus this plus this. Okay? You're adding everything. So, what is 2a plus 2a minus 1 plus, and that is an a, it's not a 9, it is an a. There we go. Okay. Plus an a. What does this equal when we want to simplify? You always want to keep things very simple. So 2a plus 2a, let's put all of our variable objects next to each other. So we have 2a plus 2a plus a minus 9. And that equals what? So what is 2a plus 2a plus 1a? Think of it just like the numbers, like what I just said. It's 5a minus 9. And that is the equation to find the perimeter. Okay? Math can be a little bit overwhelming, but if you take things one step at a time, one bite at a time, you're going to be okay. If you really liked this class, or if you want me to keep doing it, give me that thumbs up. Subscribe if you want more content, if you need help with the GED, if you need help with your high school or college algebra. I will be moving on to different subjects when it comes to the GED eventually, but I'm really hyper-focusing on just the math sections. I have videos that are scheduled to come out 5:30 in the morning and 6:30 at night every day. And I will try to keep up with that upload schedule. And then I will be doing these live classes. I'm thinking Monday through Friday at 9 a.m. every day. If you guys want more help, let me know. Communicate with me. I would greatly appreciate it. Otherwise, I hope you have a beautiful day, and I'll talk to you later.